Crowd goes wild next door. Damn. Craps game going on next door. So number 10, what's the claim that's being made?
Percentage of students with more than
U greater than
2 finals.
8.7.
Yeah, so something is greater than something.
U is greater than.
No mu. P. Percentage is bigger than
38.7.
0.37. I like it. All right, so which one is that going to be? Is it going to be the ho or the high?
High.
I like it because there's no equal sign in there. So what's the ho?
Less than or equal.
So is it a one tail or a two tail test? One tail. I like it. All I want is to find something that's bigger. All right, and you know, if I give you 2 hypothesis tests on the final, I'm going to have all the steps in one, and the second one might just say use all the steps. So look back at the first one. Do I have another one up here? No, I think I just was making room. What are all the steps here? So here's step 1A. You already got an A up there. What's the next step? Yeah, why? What can I use? What do I want to talk about? What can I use? Z or T? What is an MPQ problem? So it's not going to be T, but it's not enough to just say that. You still have to test to make sure that it's normal enough. And what test do I use in this case? Yeah, NP and NQ. Not NP hat, NQ hat, NP and Q. So what's N? Yeah, 292. And what's P? 0.387. And what's Q? Good. You just got to make sure those are both bigger than 5. And they are. They will be. Don't just write NP greater than 5, NQ greater than 5, and keep going. Do it. Right? No, and then maybe I make it, 4.98. If I was really evil. All right, and then, so, these both come out to be whatever, bigger than 5 for sure. And what does that mean by itself? What does that mean? It's normally distributed. I like it. So I'm allowed to use Z-scores. I would never use T-scores, but it's not I still got to make sure I can use something. So that's what this does. I don't care about N. I don't care what the N is. I really don't. So now that we've established what the hell we're talking about, we've established what we're allowed to use, now I'm allowed to set up my rejection region. Alpha here is 0.01. One tail up there. Z-scores, right? You can use a T-score chart if you look all the way at the bottom. .326. All right, I'm tired. You guys finish it up. All right, if, say it in words too. And then part D is Z star, and then part E is conclusion.
If what?
Yeah. I mean, what's the next step here? Here's a picture, but I always want it in words. If Z star is, then we can reject it. Support the Hirschman. Oh, it's right there, Joe. That's so funny. Where did this come from? Yeah. Getting old is fun. Memory really is the first thing to go. Huh? And it wasn't good in the first place. Here's number 11, by the way, if you weren't here the other day. We did that in class. So if Z star is bigger than that, reject the hoe. Yeah, there. Support the high. Now this is the relatively new Z-score formula, right? It's the one with the P's in it. And we stole the standard deviation part of it from the confidence interval stuff. So we got to figure out what P hat is. How do I figure out what P hat is? Really? Shit.
Yeah.
I tried to check all of them.
0.01 and 0.09. Why do your Z-score look so different?
What's happening?
Your using alpha is 0.01 and the question is 0.09.
Yeah, your Z-score is different.
Your Z-score is different.
Oh. I don't know where I got that from.
And your Z-score
Maybe the one above there.
1.34.
Yeah, 1.34, thank you.
I was like, I don't understand what's going on right
You guys are
now.
so funny. I had the wrong alpha down there, so yeah. So it's 0.09. I probably got that alpha from the problem I had it at or something.
Okay. Yeah. Alpha.
Yeah.
It's in number
Yeah.
9.
I love you guys. Yeah.
Just a quick thing, how do you find or get the p-value?
So once you get, real quick, alpha is the area in the tail of this Z-score. The p-value is the area in the tail of my Z star. They are analogous. Once I get my Z star, I can get the area in its tail. That is what we call the p-value.
Do you show how you would find it?
Yes, I will. Somebody tell me what you got for p hat. What did I get? I got 0.418.
How did you?
The numbers are different.
Okay. All right. Percentages are not a hard thing. What do I see in my sample? What do I see in my sample? For number 10, what do I see in my sample?
Oh. Okay.
122 out of...
Fluidity.
Yeah, that's exactly what P hat is. 122 out of 292. Magic is just ratio. Part divided by the whole. All right. But fewer and fewer students come out of high school understand that shit. So they get 0.418 minus, where does this come from?
0.3.
Yeah. 0.387 times 0.613 divided by 292. That's the Z score, the Z star. Just plugging all this stuff in. And I got 1.09. So if you look up 1.09, so 1.09 would be here. So So the p-value is the area in the tail that the 1.09 makes.
So you do.
I love the looks I'm getting. What's the problem? What area is in the tail that 1.09 makes? What area is here? This is an old problem. How do you find the area here? Well, if you look at 1.09, it tells you the area here. Look up 1.09. Maybe. Yeah, 8621. So that's this. So 1 minus that is the area in the tail that my z-score makes. Alpha is the area of the tail that the critical z-score makes. P-value is the area of the tail that my z-score makes. That's why we can compare the z-scores, or we can compare the areas. Because they'll both lead to the same answer. Yes. What about it? Okay, so our z-score is 1.09. Can you find the area in the tail that makes? Yes, because you can look that up. 1.09 gives you 0.8621. 1 minus that is 0.1379. That's the p-value. That's it. That's the p-value. It is bigger than this, so we failed. Right, this is our tolerance level. We'll accept down to 9% as being the acceptable probability that it's just a random variable, random variance away. So there's a 13.8% chance that we got a sample that just happened to be that far away from the mean. That's too big, right? We want less than 0.09% chance would be evidence that something is different. So that's why you can compare these or you can compare these. They both lead to the same answer. I just want you to tell me what the p-value is in this, right? That's what they report in the journals, because then everybody can make up their own mind. Okay, so we failed, right? We didn't find evidence. And now which wording am I going to use? What was the claim? Which one was the claim? The high? So I'm going to use that language. Yeah, we have not found evidence to support the claim that the percentage of students with more than 2 finals on the same day is more than 38%. Blah, blah, blah. You just copy it right out of the problem. What's that? Yeah, sort of. It's because we have to be careful. We can never say that we accept the null. A sample can't prove the null ever. So it's required to say we can't say that he's not right. We have to say that. That's why I disagree with the whole, in fact, if you get down to it in English even, double negatives are fine. It's just some old adage that's bullshit.
I was like, I don't know, trying to process that.
Oh, I see. Yeah. Well, at least they didn't say, we're not certain that we might not want to not do the not, oh my God.
Yeah.
Yes?
Can we do 6?
Okay, so,
Same.
yeah, so that one's going to be, now it's going to involve means up here, right? So yeah, number 6, what's the claim?
The average for the test to change.
Change. I like it. So it means the mean is no longer equal to what?
1.4.
Yeah. So it has been 1.43, and we think it's no longer 1.43. So which one is that? The high, because it does not have an equal sign. It's got the exact opposite. So what's the hope? So it's going to be a how many tail test? 2. Not equal 2 means it could be more or less. Choop.
See, I can do up to C. D is in trouble.
Oh, okay.
So yeah, we have the standard deviation and sample of more than 30, so we're using Z-score.
Yeah, and which standard deviation is it that we know here?
The population.
Yes, historically it has taken stat students that, but the standard deviation of that. That is for all stat students in the past. So that is sigma. Sigma known. Check. And?
Greater.
N is 45 greater than 30. Check. Z-scores can be used. So here alpha is, now here's where alpha is 0.01. And it's a two-tailed test. So what's that z-score going to be?
Negative and positive.
576.
Yeah, negative 2.576 and positive 2.576. So if z star is bigger than 2.566, less than negative 2.576, we can reject the whole. I'm getting tired. Support the high.
Yeah.
Now this is not two samples, this is one sample, right? So it's the little z-score formula. What do I have to do before I use the formula though? What do I know? I know n is 40, what was it? 45. I know that x bar is, what's x bar? 1.51. I know that, not s, I know that sigma is 0.25. So what I have to do with that?
Sigma sub x bar. 0.25 over square root of 45.
Whatever that is. I got to change it to the spread for a group of size 45 because that's what I'm dealing with.
0.0373.
0373. Yep. So then z star equals x bar minus mu x bar over sigma x bar. Good old normal z-score formula.
Okay.
So then it's 1.51 minus 1.43 divided by 0373. Yeah, it's 2 point something. 1.14. So where's that? Let's see.
It's within the.
Aw. 2.14.
Okay.
So did we make it? Nope, we failed. We suck. So we failed to reject the whole. We failed to support the high. And of course, which one was the claim? The high. So we use this language. That's it. That step there, not a difficult step to figure out which words to use. Use the words related to the one that is the claim. Claim is the high, and then use the support language. We have not found sufficient evidence to support the claim that the mean, I forgot what this was, time for stats students to complete their stats test is 1.43. It has changed from 1.43 hours. So really a big part of it is sometimes you guys try to force it to be percentages and try to use those forms, or more often you try to force something to be the means and you try to figure out what the standard deviation is. Stop yourself and just look, is it a percentage test or is it a mean test? Don't try to force it to work with one formula or the other, just see what it is.
In the final, are you gonna want to see the part about the silver trees?
Yeah, I normally make that the last problem just so I get spacing of students. Right? If I make it the first problem, I get like everybody coming up to me. Oh my God. So make it the last problem, so you can do a first or not, whatever you want to do. You have to come up and show me your scatter plot with the line of best fit. Cool. You guys doing all right? Don't worry about you guys. Make sure to make some time for yourselves. Make time for stats, but make time for yourself too.
Next week.
It's rough in college, I remember. It's not much of a life. Sometimes. Sometimes you have a little too much of a life. Then you have something called the lost semester. Anyway, hopefully it doesn't happen to you. Or maybe you should. I don't know.
How many questions is on the final?
I don't know. It's not going to be as long as this. I just had to stuff a lot of stuff into this thing. I'm going to have to let go of something, you know what I mean? Normally, my finals are like, you know, it can't be that much longer than a normal test. And to be honest, it can't be any longer than a normal test because, again, we only have as much time as we normally do, the 2 hours. So I didn't really answer your question.
Oh,
but
no, it's
I don't-
okay. I didn't know if it was going to be longer.
I can't remember specifically for my stats stuff, but normally it's in the low 20s. Counting ABC as 3 problems. You know what I mean? I hate when a teacher says you have 3 problems on the test and it turns out A through J. And you're like, this isn't 3 problems. We don't know. So if my earlier final is done early, I'm going to head over this way a little early. I don't know if there's somebody in here before us or not. So if you want to shoot to the room over here a little early, if you can, I might be here for any last minute questions or whatever.
Is there an extra credit section on this too?
There will be bonus on the final. Some bonus questions.
From the entire
Final
semester?
exam bonus questions. Huh?
From the entire semester?
Yeah, could be anything. Dude. But yeah, it could be anything I want it to be. It's bonus. Yeah, it'll,
How many you got?
This is a Italian
Alright. So a very low level answer to that would be, it tells us the area and the tail of our z-score. So if I looked up this z-score, and then 1 minus that area, I get the area and the tail that makes. Right? That's the p-value. In a broader sense, it tells us how likely it is, if the mean or the middle is where this thinks it is, how likely it is to get that result. So the smaller the p-value is, the less likely it is that the mean is in the right place. That's why when we get past a certain point, which we define ahead of time, we go, oh, that's enough evidence that the middle's in the wrong place. We can reject the guy that thinks it's there. Yeah.
Can you define the central limit here?
So as n gets bigger and bigger, the distribution of sample means gets more and more normal. When you get more than 30 in your sample, then in all the samples, you take all the possible samples of size 31, for example, and you plot them, it'll be normal enough to use the z-score chart for, and so forth, yeah. It also says that the mean stays the same. And that deals with if I took 3 people versus 1 person versus 8 people at a time, I'd still get the same average age. It's the same people. So the mean stays the same, but the standard deviation, of course, gets smaller. Because it's less likely to get 80 people that are aged 1 than it is to get a mixture of ages. So it's going to, yeah. Sometimes I wonder, people just ask me, like, does he really know this shit? Just ask him. Oh, this weird thing. I love it. Everybody's like, I don't want to leave in case somebody asks you a question. I don't have a good question. Maybe somebody else does. I don't know.
What was that? It was like measured by weight. It was something, and then measured by continuous versus
Oh, yeah.
degree. Something has to measured by.
No.
Something.
Most measurements would be continuous.
Okay.
So when we normally say measurement, we automatically think normally length or weight or height. You can argue that you can measure the number of things, but no, normally when I say the number of things, that's counting something. That's discrete.
Okay.
So it can only take on, there are 4 desks, or, right here or something. There can't be 4.7 desks,
I'm trying to think of all like vocabulary words now.
Oh, yeah. Yeah, sample and population, that should be it. You got statistic and parameter, you got nominal ordinal interval ratio, you got, yeah.
Is that gonna be?
Yeah.
Could be.
But I don't remember those two being on a test before.
I love that. Just tell me exactly.
Like trying to find it in his face. Like,
For number 4, for like the 35 choose score, how do you do the choose?
Oh yeah, so it's math, the math button. And then probability, PROB. The third one down, yeah. So you put the 35 in, and then you do that, and then you put the 4 in, yeah.
Oh,
So it's exactly like 35. Choose 4. If you have the newer one, of course, you gotta be careful. Oh, you have the old one. And then the rest of the
yeah.
times. Yeah.
thank you.
Sure.
so, for this homework assignment, I talked to you about it. I looked them up on Monday, so I just wanted to look at this. So I gave them to you,
All right.
and I don't have this.
Okay.
What do I need?
All right. I gotta find them then.
Put it on my own, and I'll text it.
You just gave them to me in class, right? Or
Yeah,
no?
but, so it was due the day of that test.
Well, you turn it in the class.